this video, we're going to be taking a look at the quadratic formula. This is the last method that we will use to solve quadratic equations. So the quadratic formula says if ax squared plus bx plus c equals 0, and a, b, and c are real numbers, then x equals this. So the opposite of b plus or minus the square root of the quantity b squared minus 4ac, all divided by 2 times a. So what is this that really saying? So this is saying that if you're given an equation in standard form, so that's standard form, then we can use this equation, this formula, to find the solutions, right? So we can find the solutions or the roots, zeros, x-intercepts, those are all the same thing, to this quadratic formula, this quadratic equation in standard form. So one thing to note is the quadratic formula can be used to find solutions to any quadratic equation in standard form. So again, this is standard form, so the standard form equation. If it doesn't look like this form, you can just change it into this form and then use the quadratic formula. So let's go ahead and try a few of these problems. So this says use the quadratic formula to solve. So the first thing that I like to do is try and identify, well, first of all, is it in standard form? So is it in the form ax squared plus bx plus c? So yes, it is, which means we are good to go to use quadratic formula. And then from there, I want to use, figure out what are a, b, and c, because I'm going to have to use those to solve. So a, remember if there's not a number written, there's an implied 1 as the coefficient. So a is 1, b is 2, and c is negative 8. Okay, so our the quadratic formula was x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So we want to substitute in everything that we know here. So b was 2. So we can go ahead and put in 2. So it's going to be the opposite of this, opposite of b, over 2 squared minus 4 times a was 1, and then c was negative 8, all divided by 2 times a, which is 1. And now you just basically go through and do all of the simplifying. So 2 squared, that's 4. Negative 4 times 1, that's negative 4. Negative 4 times negative 8, a negative times a negative is positive, and that's going to be 32. And then 2 times 1 is 2. So what do we get here? So we're going to get negative 2 plus or minus the square root of 4 plus 32, that's 36, and that's all divided by 2. Now this actually has 2 solutions in here because of this plus or minus. And really what we want to do is we want to try and simplify this if we can. And it actually is pretty nice because this number here, the square root of 36, is a perfect square. What is the square root of 36? Well, we know that that is 6. So we have negative 2 plus or minus 6, all divided by 2. And we're told that these are what our intercepts are going to be. Remember, this plus or minus really is just telling us we have 2 different values here. It's negative 2 plus 6 over 2. That's what x is equal to. Or x is equal to negative 2 minus 6 all over 2. And then just simplify. So negative 2 plus 6, that's 4. 4 divided by 2 is 2. Negative 2 minus 6, so we can think about this as adding a negative. So negative 2 plus negative 6, that's negative 8. Negative 8 divided by 2 is going to be negative 4. So then our 2 solutions would be x equals negative 4. And x equals 2. So those would be the solutions to this. Now what this tells me, since I get nice values here, this tells me that my original equation was actually probably factorable. It definitely was factorable. So we didn't have to use the quadratic formula, but the quadratic formula works and will give us those same results. So let's look at another example. Okay. So we have 2x squared minus 5x equals 9. Is this in the form, remember we want it in the form ax squared plus bx plus c equals 0. That's standard form equation. Not quite, right? We have this equaling to 9 here, and so we need that 9 on the other side. So we're going to subtract 9 from both sides, and that's going to give us 2x squared minus 5x minus 9 equals 0. So now we're in standard form, and now we can use the quadratic formula. So identify the values of a, b, and c, and then we can plug in. So a is 2, b is -5, c is -9, and we can now jump into the quadratic formula. Okay, so it's the opposite of b. So because b is -5, the opposite of that would be +5, plus or minus the square root of b squared, so b is -5 squared, minus 4 times a, which is 2, times c, which is -9. We can extend this a little bit. All divided by 2 times a, which is 2 there. Okay, so let's go ahead and do some simplifying here. -5 squared. So -5 times -5 is +25. -4 times 2, that's -8. -8 times -9 is going to be +72. And then when we add those together, we're going to get 97. So it's 5 plus or minus the square root of 97, all divided by 2 times 2, which is 4. Now, this could potentially be our answer, right? But we need to double check and make sure that 97, square root of 97, can't be simplified. Is it a perfect square? That's the question you should ask yourself first. No, it's not. Can it be broken down and simplified? Well, 97, if you go through and try and go through the process of simplifying this, it actually turns out that 97 is a prime number, which means 1 and 97 are the only factors of it. So we're not going to actually be able to simplify this. So I would actually be 100% okay and happy if you wrote this as your answer, just like this. But what does it mean? What does it mean? Do you remember what it means? It means, right, this really means that x is equal to 5 plus the square root of 97 over 4, or 5 minus the square root of 97 all over 4. So those would be our two solutions. And if you went and plugged this into your calculator, it would give you the two different values, the two different x values where your graph is crossing the x-axis. So those are our solutions to our equation. Okay, so let's take a look at another one. So we want to use the quadratic formula to solve this. It's nice, it's already in standard form, so we can just jump straight into solving. So what is a? A, again, remember when the when the number coefficient's not written, it's an implied 1. So a is 1, b is 3, and c is 12. So let's go ahead and plug into the quadratic formula. So x equals... Now the quadratic formula is definitely something you're going to want to memorize because it's going to come up a lot. And I think just through the practice and repetition, you probably will get pretty good at memorizing it. So it's the opposite of b, so it's -3, plus or minus the square root of b squared, so it's 3 squared, minus 4 times a, which is 1, times c, which is 12, all divided by 2 times a. Okay, so what do we have here? So 3 squared, that's 9. 4 times 1 is 4. 4 times 12, that is, what, 48? So it's minus 48. And then go through and simplify this. So that's going to be -3. Whoa. Sorry about that, wrong color. So that's going to be -3 plus or minus 9 minus 48, that's going to be -36, all divided by 2. Okay, so -36, can that simplify at all? Well, actually, this is a situation where, if you recall, we have a negative inside our radical. And we said when that happens, we end up with a situation where we get something called no solution. Because remember, when we have a negative in our radical, right, when we have a negative in our radical, that means that there's no number, no real number that would multiply by itself to give you a negative. Right? If we're thinking of the square root of 36, 6 times 6 is 36, -6 times -6 is positive 36, but there's no way to multiply two numbers that are exactly the same, sign included, to get -36. So with something like this, we end up with actually no solution. Now, what does no solution mean? No solution essentially just means that if you have your graph like this, that it lies above the x-axis. Sorry, that's pretty bad. It lies above the x-axis. It never crosses the x-axis, so there's no solution. There's nowhere that it touches. All right, so let's look at one more. Let's look at one more of these. So use the quadratic formula to solve. Again, it's in standard form, so we should be good to go there. So let's just jump in to using the equation. So A is 2, B is -4, C is -5. So we get x equals the opposite of b. So b is already negative, so the opposite of that would be positive. So it's 4 plus or minus the square root of -4 squared minus 4 times a, which is positive 2, times c, which is -5, all divided by 2 times a, which is 2. Okay. So what do we get from this? -4 times -4 is positive 16. 5 times 2, or -5 times 2 is -10. -10 times -4 is positive 40. So I'm going to get 4 plus or minus the square root of 16 and 40, that's 56, divided by 4. Now, I think we're going to have to do some reducing here. So let's look at 56. So 56. What are factors of 56? 56 is going to be 8 times 7. 8 is 2 and 4. 4 is 2 and 2. And in the radical, it was an index of 2, so we're looking for a pair. So we have a pair of 2's. The 7 and the 2 weren't paired, so this simplifies to be 2 times the square root of 2 times 7, which is 14. So from this, we get that x equals 4 plus or minus 2 times the square root of 14, all divided by 4. Now, we actually aren't quite done in this situation. So one thing that you always want to double check first is there anything that all of these terms, all these factors have in common? Now, we're not paying attention to what's inside the radical. In this case, what's inside the radical does have a 2, right? It's also divisible by 2, but we can't actually cancel what's inside the radical because it's not a whole number 2, it's the square root of 2. So it's not a factor that we can actually cancel out. But these two pieces have a factor of 2, and this has a factor of 2, so we have to be able to factor that out. So in the top, we can actually factor out a 2, so we can think of this as 2 times 2 plus or minus the square root of 14, right? Because if I were to distribute this in, 2 times 2 would give me 4, and then 2 times the square root of 14 would be 2 times the square root of 14. Now this 2 here can cancel with the 2 that we have in our denominator. So this ends up being 2, and that would reduce to be a 1. And so as a result, we actually get that x is equal to 2 plus or minus the square root of 14, all divided by 2. And this is an acceptable way to write your answer. If you wanted to write it as 2 plus the square root of 14 divided by 2 and 2 minus the square root of 14 divided by 2, you can, but there's no need. But you do need to recognize that this is two distinct values, one with the positive sign and one with the negative value there. Okay, so that's how you use the quadratic formula. Good luck, and let me know if you have any questions.